All right, hi everyone. This is the last section of our Unit 1 Stoichiometry Final Exam Study Guide review. And we're going to be doing section 1.13 and section 1.14, dealing with Avogadro's number. So as a quick review, remember we've been talking about the mole and what the mole is. And remember, it's kind of like the word dozen. Okay, how 1 dozen is always equal to 12 of whatever you have. 1 mole is always equal to 6.02 times 10 to the 23 of whatever you have. And so this number is called Avogadro's number because Mario Avogadro, he was the guy who figured out what this number was supposed to be. And so when we talk about Avogadro's number and, okay, what actually is it? It is 6.02 times 10 to the 23 particles. Okay, and particles is just the sciencey word for things. And so it can be, that word can be swapped out for 3 other words. It could be atoms, molecules, and formula units. Okay, so if you see in a problem the word atoms, molecules, formula units, or particles, then it will be your kind of flashing red sign that that's what you need. And Avogadro's number is always equal to 1 mole, just like your molar mass is always equal to 1 mole. And so when we look at this problem, we really just solve it the same way, except now we have a new possible fraction. So here it says how many moles of carbon atoms is in 4.72 times 10 to the 24 atoms of carbon. And so when we label what we're given and what we are looking for in this problem, we write down our 4.72 times 10 to the 24 atoms of carbon. And what we're looking for, it says how many moles of carbon. So we're looking for moles of carbon. And so one thing we see is by seeing this word atoms, it's one of these 4 words up here: particles, atoms, molecules, formula units. So that tells us that we need to use Avogadro's number in our T-chart. And then we look at our chemicals. The chemicals are the same. So there's no need to use a mole ratio. I don't see grams in this problem, so we don't need molar mass. All we need is Avogadro's number. And so we write Avogadro's number as our fraction, so 6.02 times 10 to the 23 atoms. We're going to use that word atoms instead of particles because that is what is in our problem, of carbon, divided by 1 mole of carbon. And remember, we can either have it that way or we can flip it, depending on what we need in our T-chart. So when we set up our T-chart, which I'm going to make that a little thicker of a line. Okay, when we set up our T-chart, we put what we're given right here. So we start out with 4.72 times 10 to the 24 atoms of carbon. And we know that whatever we have here has to show up at the bottom of our chart. And we see that in our fraction, that's at the top. So we're actually going to need to flip this fraction so that the 6.02 times 10 to the 23 atoms of carbon is at the bottom and the 1 mole of carbon is at the top. And this is great because we see that atoms of carbon will cancel out because it's present in the top and bottom of our fraction. And then we can see that this, what's at the top, matches what we're looking for. So we're done. And we multiply by 1 and divide by this. Now, the hard part here is actually putting it in your calculator. So it depends on whether or not you have a Android phone or an iPhone as to what method you use. So you might want to really pay attention to that. So if you have an iPhone, which is what I have, it's kind of easier for me to walk you through it. The way you would put this in your calculator is, well, your calculator in general will say 4.72 times 10 to the 24 times 1 divided by 6.02 times 10 to the 23. But in an iPhone, there's a button that represents this times 10, and it's 2 capital E's. So if you turn your phone sideways so that it will give you the full calculator, you can type in 4.72 EE and then your 24 times 1 divided by 6.02 EE23. So you just kind of replace that for the times 10. If you're on an Android, there are multiple types of calculators, so if you're confused, I might need to show you. Some do have this double capital E button, some do not. If that's the case, so this is what you would do for an iPhone. If you have an Android, the most likely thing is that you'll need to put it in parentheses and say 4.72 and actually type in times 10. And you should have, it's called a caret, but it's like an arrow pointing up. And then you can do 24 and then close your parentheses. If you don't put parentheses around a number in scientific notation when you use that times 10 with the caret, it'll mess up your order of operations completely. So times 1 and then divided by parenthesis again, 6.02 times 10 to the little caret, 23. So make sure that you try that out in your calculator. When you do that, you should get 7.84 moles of carbon as your final answer. If you get something that says like times 10 or e to the 48 or 50 something, you've put it in your calculator incorrectly. Now let's take a look at this next one. So this one says how many grams of NaOH, or sodium hydroxide, are present in 4.89 times 10 to the 25 formula units of sodium hydroxide. So if, again, we're labeling what we're given and what we are looking for in this problem, we're given 4.89 times 10 to the 25 formula units, which I kind of abbreviate as form units. That way it doesn't take up as much space, sodium hydroxide. And we're looking for grams of sodium hydroxide. Now, when we do this, we see, okay, this word formula units, that tells us that we need Avogadro's number as a fraction. And then the fact that I have NaOH and NaOH, those are the same, so I don't need a mole ratio, but I do see grams, and that tells me that I need the molar mass of NaOH, because that's the chemical right here beside it. So we need to go ahead and write those out. So Avogadro's number is going to be 6.02 times 10 to the 23, and unlike this problem where we used atoms, since this one has formula units, I'm going to use that, and I'm actually going to abbreviate it even further to take up less space, over 1 mole of NaOH. And then we're going to put the molar mass fraction right here, but I'm going to calculate it over here. So for our molar mass, remember, when we have grams, that means we use our periodic table. So we have sodium, and we have oxygen, and we have hydrogen. We have one of each of them. There are no subscripts. So we multiply by their mass from the periodic table, which is at the bottom of the box. And since I'm multiplying by 1, it stays, the same. But I'm just showing out, and that should be 1.01. But I'm showing all my work to, make sure that that you all see the work completely shown out, but this is what you want to do as well, because you want to show your teacher that you know exactly what you're doing. And when you add them all together, you get 40.00 grams per mole of NaOH. So the way we put that into a fraction is we say, okay, 40.00 grams of NaOH, and then the slash mole, that goes on the bottom. We've got the line, the slash, and then we put the mole. It's 1, and our chemical is NaOH. And so now that we have our fractions, we can go ahead and set up our t-chart. So when we set up our t-chart, we put what's given to us here. We say 4.89 times 10 to the 25 formula units of NaOH. And we know that whatever unit and chemical we have here also has to go at the bottom. So that means I'm going to need formula units of NaOH at the bottom. The only fraction I have, I've got two fractions, Avogadro's number and molar mass. That's right here. But because it's at the top, that means I need to flip what's on the top to be at the bottom. So 6.02 times 10 to the 23 will go at the bottom, and my 1 mole of NaOH will go at the top. But this doesn't match what we're looking for. So that means we definitely can't stop there. And we know that because we already said that we needed two fractions, and I've only used one of them. So I put moles of NaOH at the bottom to stick with our pattern. And I know that moles of NaOH is technically in two places, but since I've already used Avogadro's number, I can only use molar mass now. And it's already at the bottom, so I can put my 1 mole of NaOH at the bottom and my 40.00 grams of NaOH at the top. And we see that this matches what we're looking for, so that makes us happy. And we can put it in our calculator. So we multiply by what's at the top, and we divide by the numbers that are at the bottom. So in our calculator, that would be 4.89 times 10 to the 25 times 1 times 40.00 divided by 6.02 times 10 to the 23 divided by 1. And you should get 3,249.17 grams of NaOH. So if that is not what you got, make sure that you put Avogadro's number and you're given into your calculator correctly with that times 10, and really look through that. If you really think I might have done something wrong in my own calculator, let me know. It's possible. But I would really recommend checking your calculator first. So this is kind of an example of how we do that. And remember, guys, being able to label what you're given, what you're looking for, and figuring out which fractions you need at the very beginning will save you a lot of headaches in the long run.